in this problem, we're asked to compute this limit here as h approaches 0. And immediately we see a problem in that there's an h in the denominator. So if we just try to plug in 0 for h right away, we'll be dividing by 0, and that's undefined. So we're going to have to do a little bit of algebra in order to get to a point where we can plug in 0 safely. So the first thing that I'm going to do is multiply both the top and the bottom by 25 times the quantity 5 plus h squared. And we'll see why this helps us in just a second. So from here, we're going to see that in the numerator, some of these terms are going to cancel. It's going to make our life a lot easier in this problem. So here, the 5 plus h squares canceled, and here, the 25s cancel. So what we're left with is 25 minus 5 plus h squared all over this big guy right here. All right. So next step, we're just going to break this open and see what we get. So when we're squaring this guy, 5 squared gets us 25. We get 5 times h gives us 5h, but there's going to be 2 of those. So it gives us 10h. And then finally, there's going to be an h squared at the end. And this is all going to be over the same denominator that we had before. So now you notice that we have a 25 and a minus 25 here. Those are going to cancel out, which will leave us with a numerator in which every term has an h in it. So from here, we can cancel out an h from the top and the bottom. We're left with the following limit, which is much, much easier to evaluate. Probably even do it in your head. So from here, since there is no longer an h in the denominator, we can just plug in 0 for h to evaluate the limit. We get negative 10 on top. Plug in 0 for h here, we get 5 squared is 25. 25 squared in the denominator. Simplify that on your own, you're good to go.